champions, and welcome back to this Tuesday science video talking about wind energy. So far in our unit on renewable and non-renewable energy, we've spent a lot of time looking at some non-renewable resources that we use to power our cars, power our homes, power everything in our lives. Now we're going to be looking at some renewable resources. So those non-renewable resources, nuclear energy, coal, petroleum, natural gas, all those things we use at a rate far faster than they can regenerate. And in an often case with coal and petroleum and natural gas, those things have been building on the decomposed remnants of organisms, plants and animals or dinosaurs, for hundreds and thousands and millions of years, buried under layers and layers and layers of sediment, pushing that down, and all that pressure makes it. With uranium that we use for nuclear energy, there is only a finite amount that planet Earth started with, and there's only a finite amount that we can use. It will not regenerate. So let's look at some renewable resources, the resources that we can use over and over again that do not impact how long we can use them. Because right now we've got plenty of it for now, but there's no saying how long all of these resources will last. So wind energy is something that we can harness that naturally occurs, and we can't really stop it. Wind just happens. More so in some places than in others. Arizona, we rarely have windy days, but in other parts of the world, wind is constant. And if we can use that energy, it might make life better. So thinking about our big question for today is, how do people use wind as a source of energy? How do people use wind as a source of energy? Well, the sun heats the sand, trees, soil, and shallow waters around a tropical island. In the afternoon, the air over the island is very warm and rises higher into the atmosphere. This causes cooler air from over the sea to blow in. The moving air produces waves on the water. Boats that had been using their diesel engines are able to hoist their sails and use a free source of energy. This is wind energy. Near the island stands a series of tall wind turbines. The blades of the turbines rotate faster as the wind picks up. Inside each turbine is a generator that produces electricity with each rotation of the blades. The electricity transfers through wires to a small power station. The station shuts down its noisy diesel generator, and for the afternoon, the entire island is powered by these wind turbines. Converting wind energy to electricity. Well, for centuries, windmills have converted wind energy to mechanical energy. The blades turned a shaft that was connected to gears. These gears helped to operate a millstone for grinding down grain into flour. Modern wind turbines that convert wind energy into electricity have the added step of converting mechanical energy into electrical energy. In a modern wind turbine, the blades are attached to a large shaft with a large gear housed inside the turbine. The large gear rotates and is engaged with a smaller gear. The smaller gear is attached to yet another shaft inside a generator, and the shaft rotates between 1,000 and 1,800 times per minute. The direction that the turbine blades face can be changed so that the blades capture more or less wind. This allows engineers to prevent blades from spinning too fast when the wind is blowing too hard, or it can prevent the blades from spinning at all when the wind is too weak to generate power. Okay, so if I look at this model, we've got the blades of the fan, and it's turning the shaft, which hits this gear, turns another shaft, and connects to gears and gears. The rotational power of the wind transfers energy from gear to gear to gear to make it into the generator, which powers and rotates much like the generators of a hydroelectric dam, of a nuclear power plant, or a coal plant. It's all about that spinning generator created by some movement, whether it's steam powered heating up water and that steam powering the generator, whether you do that through coal or nuclear energy, or you can use wind power to power that same kind of generator. Okay. Things to consider about wind power. Wind is an abundant renewable resource, but it is not always reliable. Some locations can be windy one day and calm the next. Some have winds that blow for weeks and then periods of calm. Others have breezes that are steady but not strong enough to turn large turbine blades fast enough to generate electricity. A wind farm consists of multiple turbines that are placed together. Wind farms can cover vast areas. Turbines need to be spaced far enough apart that each one receives wind without disrupting how the others operate. Far enough away that they're not spinning into each other and crashing. Okay? Some wind power projects have been controversial because some people do not like the appearance of the turbines across the landscape. Another factor that must be considered is how the turbines will be maintained and monitored. A turbine anchored to the ocean floor 10 miles from the coast may be more difficult or expensive to maintain and monitor than turbines on land. On the other hand, the offshore turbine may produce more power when you're out at wind. If you've ever traveled out to San Diego, you've probably driven along Interstate 8 through Indio, California, where you see the massive wind farm of all those turbines shortly before you get into the mountains. And those wind turbines certainly do help to power up most of Southern California. Okay. Wind energy transmission and storage. Well, wind energy harnessed by a turbine becomes electricity. Transmission, or the movement of electricity, usually involves power lines that run from a turbine to the nearest electrical power grid. The grid is the network of power lines, towers, underground cables, transformers, and other technology that distributes electricity to homes, schools, and businesses. When a wind farm generates electricity, the people who operate the grid can direct the electricity to specific parts of the grid and keep track of how much it is being used. Electricity can also be stored in batteries because wind power is dependent on wind, which is not always blowing. Batteries can help make wind power more reliable. Individual homes or neighborhoods can even have their own small wind farms. A large battery can store the electricity for later use. Wind power can be combined with other electricity sources. Okay? So a word to know is a power grid. A power grid is a network of power plants, transfer stations, and power lines that supply electricity within a region. And so your modern electric companies, which for Arizona are either APS or SRP, they monitor where all the power is going and where all that power is coming from, which in our case would be from most likely the nuclear power plant in Palo Verde. Some hydroelectric dams power some of us, but they measure how much energy is created and transfer it to the right places in the right amount so that your home doesn't receive too much energy or not enough energy. Same thing happens when you are using wind energy and all those turbines keep spinning and spinning and spinning. That power is sent to specific places and the power grid monitors where all that power is going. If there's ever a blackout or no power, they're able to identify where that problem is and fix it as quickly as they can. So, a lot of fascinating things, all powering our world around us with this wonderful wind energy. May not be the most helpful for us here in Phoenix. However, in other parts of the world, it certainly does have its benefits. I think in Thursday's episode, we'll be talking about something that might appeal very much to us Phoenicians here in Arizona with a source of renewable energy that we are trying our best to harness. So, thank you for your time. You've got 5 to 10 questions to answer on Google Classroom. Stay awesome, and I will talk to you real soon.